Deploy secure software. In this section, you would see how to automate software deployment process by treating infrastructure as a code techniques. You will see chaos monkey style testing to examine how system behaves in an unusual circumstance. Infrastructure as code is the first video of this section. In this video, you will see how configuration of infrastructure should be secured. Infrastructure configuration and deployment face certain key risks. The default configuration may not necessarily be secure, so you should assess the security configuration to start with, then take steps to harden the configuration. Keep on monitoring the infrastructure continuously so as to optimize on configuration settings. Deploying applications and data in IaaS does not protect you from vulnerabilities and weaknesses in applications and data. The cloud provider is not responsible for the workload security. Check for weakness by doing regular scanning. Track compliance and make plans to increase the compliance level. You may be surprised to know that it is quite common to uncover hidden assets lying in some corner. Look for such ghost servers or unwanted workloads and take steps to remove them. There are certain best practices which should be followed. Isolate different workloads and tenants. Have a protective firewall around critical resources. It is a good practice to have identity-based access and use techniques like single sign-on. In certain situations, due to business requirements, compliance to industry standards like HIPAA and DSS is important. In order to verify the level of compliance, you can use different checks and balances. All the compliance standards want to have sensitive data encrypted. Different types of users should have different types of access rights. Docker is an open source container platform for developing, shipping, and running applications. Docker enables you to separate your application from your infrastructure so you can deliver software quickly. With Docker, you can manage your infrastructure in the same way as you manage your applications. The isolation and security allow you to run many containers simultaneously on a given host. Docker uses a client-server architecture. The Docker client talks to the Docker daemon, which does the heavy lifting of building, running, and distributing your Docker containers. The Docker client and daemon can run on the same system, or you can connect a Docker client to a remote Docker daemon. The Docker client and daemon communicate using a REST API over Unix sockets or a network interface. An image is a read-only template with instructions for creating a Docker container. Often, an image is based on another image with some additional customization. For example, you may build an image which is based on the Ubuntu image, but installs the Apache web server and your application, as well as the configuration details needed to make your application run. Namespaces provide the first and most straightforward form of isolation. Processes running within a container cannot see, and even less affect processes running in another container or in the host system. Each container also gets its own network stack, meaning that a container doesn't get privileged access to the sockets or interfaces of another container. C groups control container access to CPU, memory, swap, block I/O. SE Linux is stored in the Docker engine and the default profile is applied for the engine and its containers. Docker by default allows only 14 of the 37 Linux capability groups. More can be dropped or added as required. Fine-grained per syscall control is available via ccomp. A default profile limiting many syscalls is already applied. User namespace processes remap root to an unprivileged ID on the host.